Hello, everyone. I've been recently working on ML systems for like machine learning systems for ad click prediction or like video recommendation, etc. The meanwhile, I'll still practice the system design, mocking the system design interview for other systems as well. For example, today we are going to work on a payment system. For payment system here, our requirements will be more support customer or user pay to the seller for the orders, like e-commerce, etc. The secondly will show the aggregated financial transactions. The third will be will also support the platform, the system to pay seller. We'll just it's like the payout. So here more like pay in from user to the platform. This one will be like payout from the platform to the seller. So it'll be like the whole ecosystem of the payment platform. That's the functional requirements. Let's also talk about the non-functional requirements. We will have the firstly for any payment related or transaction related system, reliability and fault tolerance will be the top requirements. So there will be like no single point of failure and the system should be like highly reliable. The second requirement would be for example, we want to make sure that the transaction is accurate or is aligned with both parties, like the seller and also the user. So at end of the day, we'll have reconciliation in the reconciliation in place. This third one will still support scalability and high availability, etc. We'll talk about that quickly. So for our system, the main entities will be the payment orders. So we may have, for example, 10 millions of orders per day. Will be a very large amount of data per day. And then we can quickly calculate the QPS around that will be 10 million divided by 100K. That's all the seconds we have. So that will be 10 million, then 10K, right? 10K by 100. Let's do the quick math here. 10K by 100. So that'll be like 100 QPS. That's not big volume. Even if you times by 2x to 3x, that give us like 200 to 300 QPS. That's the QPS. And then we also talk about the data storage. For the data storage, here like we said, we'll have like 10 million per day, and then we'll have for each order, we may have like 1 KB data, including the order status, timestamp, the users who placed that order, and also the amount, the amount we need to pay to the platform or to the seller. So that could give us like 10 gigabyte of data for per day. So it's not a big amount of data. Any normal moderate, any modern relational database will definitely can do this. Even we can like scale or like shard the database with more replicas. So yeah, data data size is also not a big deal. So the challenge here will be more accurate of the data, and we want to track all the users' transactions. Okay, that's the high level requirements. And then let's start with the high level design. So now we know the requirements. The high level design will mostly work on the functional requirements. We will start with the API. So here we'll support user to pay the salary. So we'll have a HTTP post API for the payment, and then we'll have the JSON format of the data. So here we can say we have the user, etc. We will have the timestamp when we place this order. We will also have the order information, payment order. Here we will just have like one request per one order. However, we can support, let's extend that to, we may have like multiple orders, order 1, order 2, etc. So here, like, yeah, we may have multiple orders, and then we'll have like two, like we'll have payment to who, right, etc. That's like the very high level API design with the parameters. We will also support show aggregated financial transactions, right? So we'll have the V1. Oh, before that, we need to so support user pay. Of course, like user should be view the payment orders. So we'll have the payment ID, and then we'll gather all the information with the JSON format. Here we will need also support all the financial transactions aggregated. So we'll have like here, we can say transactions. Let's aggregate it by time. So then we will have the parameter here for the aggregation. For example, first parameter could be either day, month, week, year, etc. Or can configurable, and we may sort by timestamp or like latency of the data, latest of the data. Okay, so that's the transaction, the third API, system to pay seller. So yeah, we can also, but that's like the user-facing API. For that, we can just pay the, we can talk about that later. Very similar to the paying system, but just the platform will handle that. For example, maybe at end of the day, an invoice or something, pay to the pay to the sellers. Now we have the API. Let's start to draw the diagrams. So we will have the UI of our platform. We have the app, our app. Then we will have the load balancer. The user request comes in, and then they placed the payment order, right? So they have the API code to our system. So we'll have the payment service here. So we have the request from the user. The payment service will try to store all the data in our database. And then now we have the request. and then we need to process that request, right? So we'll have the order service here for the payment order. So we'll try to call the order service to process the order. We will also store the order in the database here to track the order status. And then our order can call the third party like payment provider. For example, Stripe here. We have different maybe a Stripe, maybe if credit card, maybe just like if we can call Visa or MasterCard, etc. So just like third party. Will not cover third party payments service providers. Will not work on this by our own for sure. So then we may pay the order, we have the status updated, we'll update our database, and then our payment system will got the status change, right? The order was already paid, etc. Internally, we will store the transaction. We'll call it like ledger system. And for ledger, we'll have the database to it's double A-train booking, etc. We'll also have a database for that, so you can see we have database everywhere. And then we will also have a wallet. So the wallet is for the seller. We'll have a database for that as well. Okay, so let's quickly go through the functional requirements. Support user pay, yes, user can pay, and then we'll store that order record in our database. View the payment orders, user can view, just query from the payment system, from the we will query the data. We'll query the data from the database. Show aggregated financial transactions. Yes, so in the payment system, we will show that. We will have the actually we can have another service here. For read. So it will actually, that's called query service. It will query all the records from our database and with the aggregation. Here we may have the cache for aggregated results. And it depends on the data volume. We may do the aggregation on the fly, or we may like pre-aggregate, and then we will show the results. We will not dive deep into here, but if you are interested, feel free to take a look at our other system design for the aggregation. For example, top K problem, etc. It's already aggregated, like streaming or even batch jobs. Now let's just talk about the other functional requirements, system to pay seller. So we have the wallet here. We have the record of all the sellers, and we'll, at the end of the day, we'll generate an invoice. We'll pay the vendor with another like third-party service. Okay, now that's the high-level design. We want to talk about all the non-functional requirements, also dive deep. So let's dive deep right now. So deep dive into the non-functional requirements and also the potential bottleneck of the system. Firstly, reliability, fault tolerance. To make sure our system is highly reliable, we need to make sure all the components will like will high availability and also no single point of failure to like for the fault tolerance. For example, for the payment system, load balancer, etc., we'll have the first requirement on the reliability and fault tolerance. Normally, we will have the load balancer plus the auto scaling to work on that. For efficiency, we may have a cache, but here we will not talk more on cache. So for the older system here, like payment, order, we will auto scale. And we will add the, we'll talk about that later. For now, just like for that, and also that's the service. For database, we will use primary plus replica model to make sure we have multiple copies of the data. So if primary is down, we have other replica to be the primary, or if replica is down, we can just bring up new replica. We will maintain strong consistency for the database. Since our query QPS will be just like hundreds of QPS, any modern relational database will handle that. So we talk about that. That's our first talking point. The second one was the reconciliation. Yes, so for the payment system, it's quite important to make sure our system and the third-party system, they are 100% accurate or like aligned. So secondly, let's talk about reconciliation system service. So let's add that. We will have a new service here called reconciliation service. At the end of the day, we will try to download the record from our third-party PSP service, and then we will compare that with our internal system, like the ledger and the wallet. So then make sure all the records, they match each other. That's the reconciliation service. The third one will be here. When we got the request, we just call the order service and the third party, which will not scale. We will also take care of the scalability here. We don't want like the like we will not need these like synchronized service calls. That's why we here we will add the queue for Kafka, and then the payment will just drop the event here, order will consume the event. Similarly here, we'll also have a queue. We can call Kafka, and then we will drop the event here, and then no, we do not need that. It's a third party. We don't need to have that, so we just call that third party. Yeah, consume the queue, etc. Okay. So the third talking point will be just a Kafka queue. So here for Kafka queue, since now it's queue based, we need to make sure we need to make sure the message or the there's no error or no failure. So we'll make sure like, okay, exact once delivery. For exact once delivery, there'll be like at least once and at most once, right? So for at least once, we'll add retry queue, retry topic. Like we'll keep retrying still cannot be successful delivered, we'll have the DROQ, then our on-call will actively look into that, or will get paged. The at most ones here it's like, okay, if the user keep trying or double clicked on something here, how to make sure we didn't double charge the user. Here we will use a UUID, or we will use some like idempotency, potency key. Idempotency. Okay, I don't know what here is wrong, but yeah, you got what I mean. Potency. Okay, yeah, that's right. So yeah, no. Okay. So idempotency key, for example, we can use UUID, or we can use the database key, database primary key as the UUID. So here, when we store the payment request, or we have the primary key. So if the second request comes in, yes, it will not insert that into our database, which means we already have that record. That actually not the Kafka, it's the at most ones. That's Kafka Q. That's actually the service for no dupe. So it should be here on the payment system. So it will be in this database. Okay, so now we talk about that, the table schema. It's very simple for the table schema. We'll just use the relational database. We'll have a user, we'll have like payment order, etc. We'll not cover that. We can quickly cover the query service here at the fifth talking point. So for that will be the aggregated query. We can do on the fly, then store in cache, Redis, etc. If we have a lot of records, and we will not do that. We will do the pre-aggregation. We'll do like batch jobs. We'll have the rule ups for like days, months, or years. I prefer this approach, pre-aggregation. So that like, yeah, they will store the data, then store the pre-aggregated data in database. So that's like the query, which is query that. Cool, that's the system design for the payment system. Thanks for watching the video. Hope you enjoy it.